Hello, Mr. Gazda here, homework 42. I'm refilming this now so that it doesn't take as long. The video was kind of long. So here we go, without further ado. This is good practice for all the mapping skills, and in the past, students have done poorly on this homework. And with the test coming up, you want to make sure you get it right. So here we go, not to waste time. On the map below, you're going to draw these these isolines, 20 feet, 40 feet, 60 feet. Key thing here, look around what you have. This is the bay. That must be sea level there. So let's start with 20. Can I find somewhere that's 20? Sometimes you can't find a 20 and you have to estimate where it might be. So here's 20 between 17 and 25, and you always got to find the next spot to go, and then the next 20 would be there, and then you go like that. And then the next 20 is going to be, no, too low, too high, over here. Okay, and no, I see 20 there, so I can go right to the dot. That's 20, and then the next 20 is going to be between 28 and 17. I go there, and by now you probably have a good sense. So what I'm going to do is this is basically what it should look like. It should look something like this. It should look like that. Okay. Your lines. Now they look a little different, but make sure they go like that, and they should always be in pencil. Okay, so next up is we have in what direction does Elma Creek flow? Okay, so the best way to answer that is to use your map that you drew the isolines, because they're always going to form V's. So here's a V here. Okay, when I say a V, this is the V formed by the contour line, like that, and this is a weaker one here, but it's a V. Those point uphill or upstream. Therefore, the river, Elma Creek here, is flowing. I'll draw a big arrow on. It's flowing this way, the opposite direction those point. That's the key thing. Therefore, if I look at the compass direction, that's north. Therefore, the river is flowing south or southward. Also, too, general compass direction could be southeast, southwest, northeast. The general compass direction, we don't just mean the 4, north, south, east, west. It's really 8 general compass directions once you get the northeast, northwest, southeast in there. That's important to know. Next up, so this, calculate the gradient between point A and point B. Okay, so the gradient, the first thing you want to have is a reference table. What is the formula for gradient? Know that it's there. Change in field value divided by distance. Change in field value divided by distance. Okay, now change in field value in this case, because we're doing elevation, is going to be the elevation change. So A is right here. A has an elevation of 60 feet, and then B is, see, points right there, is 10 feet. So the change, 60 feet is 50 feet, and then the distance between them, so that is how the elevation changes. The distance is going to be in this direction, this sort of horizontal direction. And the way you do that is using the scale here. Best thing to do is to go like this. Mark your A and your B and get it right on there. I'm doing it in pen so that it's just easier for you to see. So that's B, that's A. That's the distance there. Now I can go here. Now, I often want to go like this, but then I block the numbers. Sometimes it's good to go from the top, put that right there, and realize, I'm landing right on there. So this is in miles. That's 2 miles. That's 3. That's 2.5 miles. 2.5 miles. And key thing is to do the unit math here. Feet over mile. They don't cancel out or simplify anyway, so your answer will be in feet over miles. And then make sure you do math on a calculator. 50 divided by 2.5 equals 20. So the answer is going to be 20 feet per mile. So for every 1 mile you go in this direction, you're going uphill by 20 feet. Okay, you do the same basic idea for the next one, and just this again to save time. This is what you should get, 61 divided by 2, and the answer should be 30.5 feet per mile. It does say express your answer to the nearest tenth, or round to the nearest tenth, 30.5 feet per mile. So it's going to be steeper in this section. You can probably see about the lines being closer together, or especially if there were more of them. But so that is that first page. The second page, and this is one that kids often kind of mess up here. So on the diagram on the right, circle Polaris. So it shows you some stars and constellations. It doesn't really show you Polaris. You have to label it. So the Big Dipper is key. Big Dipper is key here. So use these. These are your pointer stars. They point out to a star. That's too close. It's like, I think it's about 6 times out, and it is this star. Now it's nice. It is the last star in the handle of the Little Dipper. So if the Little Dipper is labeled, that really helps. Circle Polaris, and you really should be labeling it Polaris. Usually you always want to label it. Sometimes you label it A, label it B, or in this case label it with that is Polaris. Know that. That is key. And it's called the North Star. So, time zones here. So let's get the time zones going. So, time zones are on this map, and it has Pacific Mountain, Central, Eastern time zone. You may be familiar with that. We live in the Eastern time zone. And all of these go off the gray shading. The gray and white shading is key. More important than the longitude lines. This is how they're broken down in our country. So if the time at Buffalo is 5 a.m., what time would it be in San Francisco? So you have to recognize that Earth does rotate this way. Therefore, we're ahead here. So if I often think of it, if the sun is rising here, we're rotating into the lit up part of Earth, it's still dark over here. So that's how I kind of remember that this is ahead and this is behind. And everyone is an hour. So 5 a.m., I can go back. Central time zone will be 4 a.m., 3 a.m. It would be 2 a.m. in San Francisco. 2 a.m. and that is important. If it's 11:30 a.m. in San Francisco, what's the local time in Denver? And that's the word that we use, local time, related to the time zones. So 11:30 here, you have to realize this is 1 hour. Now we're going ahead. So you got to just know this is ahead. So, and we're one time zone over, so it will be 12:30 p.m. because now this is a little bit past noon, half hour past noon, p.m. in Denver. Okay. 8. The time in Denver is 8 p.m. What time is it in Buffalo? So now, 8 here, and then I'm going ahead. 8 p.m., 9 p.m., 10 p.m. in Buffalo. Answer, 10 p.m. 9. The basis for the time difference between adjoining means next to each other, time zones on Earth is, it is rotation, spinning on the axis, revolution is going around something, okay? Okay, so like this would be rotation of this marker, and this would be my pen revolving around the marker, okay? So Earth revolving around the sun takes a year. This is about the rotation of Earth, and it is for our 15 degrees per hour rate of rotation. That is key. Honors, try that one. Those people, I encourage people to try it. And then come see me. I don't give the answer to that. That one's challenging. People have trouble with that one. Next up, we are on this one. So, ISO lines. This shows snowfall amounts. So now we're doing how deep the snow, how much snow fell in 84, 85, winter season. And it says draw the 120-inch ISO line. I have this on for honors. You don't need to do it, but I love kids who actually attempt those. It's good practice and it's good testing yourself. They're a little more challenging. This is what they should look like. I went over them in red. So what you have here is this is the 120. That's the one you had to do. That's the 140. Notice they get really close here, and they shouldn't touch. I think the marker kind of bled, but they should not touch at all. And then the 85 goes like this, and we draw it off to the edge of the map here because we don't have, the snow doesn't build up in Lake Erie, but that's generally how we do it. Okay, so 13, calculate the gradients between points A and B. Show your math below. This is something that kids often get wrong. So, gradient, let's get the formula back here. Gradient is right here. Change in field value divided by distance. So, I do encourage change in, I'm abbreviating, field value divided by distance. In this case, field value is not elevation. It is amount of snow that falls. So this is going to be snowfall shown in inches. It's 120 inch. So A and B, where's A is 160. A is a 160 inches, so 160 inches. And then B, where's B here? Oh, B is right there. I got a little messed up, but that's 120. So that is 120 inches. So the change here is 160 minus 120. That's 40 inches. And then you want to figure out the distance here. And again, you're going to use some scrap paper. And you should really mark A and B right at the dot as carefully as you can. A and B right here. So that's the distance. And then I go like this. and you should get, it's like dead on 20 miles. They made this so that it works exactly like that. So 20 miles. I do encourage everyone to do the units first. Inches per mile. So that's going to be your answer. It's going to be in inches per mile. And then 40 divided by 20, you can do it on the calculator, and you're going to get 2 inches per mile. So it's the inches per mile that people often get wrong here. So that means that if you go here, all these towns, and every mile you drive, they got about 2 more inches of snow on that particular winter. So that's interesting to do. 14. In the diagram below, what is Fred's latitude? This is one people often get have trouble with as well, and you can tell the latitude. So this shows the sun going through the sky, north, south, east, west. The only clue here for latitude is Polaris. It's labeled clearly. That is the North Star, and this angle here between the horizon and Polaris in the sky, which is going to be 42, that tells you your latitude. So that's 42 degrees, and his latitude is 42 degrees north. Okay? If you don't have degrees north on it, it's wrong. You can't just write 42 degrees. It has to be degrees north. That's what latitude is. So that's important. Now I'm going to take a turn here and say, match up the number here with your last name. Okay? Find the number, you're going to write it next to your name. So for instance, if your name is Chris Farron, you look at F, you number 60. You write 60 right next to your name and circle it. Okay? Please do that now. Alright, now we're going on to the back of this. So, on the back we have this. So, in what general direction does the stream south of X flow? So, where's X here? I got to find X. This is the stream. I'm going to highlight the stream. This is the stream the question is referring to. What general direction does it flow? Does it flow this way or this way? Well, you're going to use the V's to tell you, and the V's point like this. V's point like this. They point like that. So, the V's point that way, so the stream flows that way, and that answer would be let me see, flows that way, towards the east. It flows towards the east. It's probably the best answer. Whole thing east, maybe a little northeast, but east is really the best answer. I think in my answer key I have northeast works too. In what general direction does the stream directly north of E flow? So that is, here's E, northward of E is this stream here. Okay? So general direction, I guess, the idea is, and the V's are pointing like this, so the stream flows this way. So I think the best answer is probably southwest. Southwest. In general, people get confused down here, but in general, my point here on the question is that it's southwest. What is the elevation of point A? So, key, contour interval is 100 feet. Contour interval is 100 feet. And this is 1,000. This is labeled at 1,500. Okay, so then that's 1,600, that's 1,700, and it's feet. So I'm hoping people can do that and get there at 1,700 feet. 17 and 18, the latitude of point G include minutes and the compass direction. That is key. So latitude of G, where is G? G is right here. So I guess what I expect people to do is go like this, okay? And so this, realize that that's the latitude line, so we're about here. And then you got to look, that's 42 degrees in 10 minutes. That's 42 degrees in 7 minutes. Okay, so this is kind of zoomed in. So I'm saying there's 3 minutes here. So that's 7. There's 1 there. So that's probably 8. And then 9 is probably about there. 9 minutes, and that's 10. So the best answer is 42 degrees and 08 minutes. And that is also going to be, well, you got to think about where 0 would be. I'm going up this way. So 0, the equator, would be way off the page this way. So all of this is north of the equator. Therefore, it is 42 degrees 08 minutes is that little symbol, and then north. And that is the format that is drawn. So you have to write it like that. In addition, what do I have? I have longitude of X. Longitude of X. So now I'm going like this down to here. You can go up to the top, but I'm going down here. So now I'm here, and I have 7635, 7632. Look, they count this way. Okay, so this is estimating. That's 32, there's 33, 34, 35. So this is probably 33 in here. So that's 34 minutes. And it should look like this. 76 degrees, 34 minutes. And because it goes up this way, that means that my 0 has to be way off the page over here to the right. And that all of these are west of the prime meridian. So this should be west. Okay. Now the last one's a little challenging to check. It should look like this, everyone. Okay, I'm saving you some time. So this should dip down here. It's a little challenging. 1400 to 1400. It goes down, and then has to go rounded, be up. Don't touch 16, but it can't just skirt along there. Make sure it goes through all the X's. It goes below 1000 to there and goes like that. If you want to check this, and you really want to stay on top of it, I have the answer. I have the plastic answer overlay. Come find me. I have it somewhere here. Here it is. Look. And this is how we really check it. You put it over and check it like that. So I can lend you this if you really want to check it. That's the most best way to do it. So thank you. I'm Mr. Gazda. Gazdoni Productions signing off.